Hello and welcome back. I'm sure you enjoyed that little stretch and got your energy back flowing. So now let's go and write the use at write and read. So to do that, you need two more functions. So I'll just copy this. You're going to write and read. So you need user 2 underscore write of int character as your argument, and then you're going to read the user2 underscore read of wide okay. So copy these two. We need it to write the function in here. So I'll copy this and the read function will be that. Okay. So what is it in the write function? So you need to make sure first check the transmit data register will be empty. So to do that, I'm going to simply write the a while function, which I'll explain to you shortly. While of not equal to, you need the status register check. So you need this register, copy this, and you're going to AND with user enable. So that will be 00080, I think 080, and open the bracket, and you're going to see the output from the data register. So you need the data register and calling the character in. So go there, equals character. Equals, you're going to channel that with character that with setting the bit to transmit 0 cross, it's a 0, sorry, not O, 0 cross FF. Okay, so you're going to write this in the user2. So you need to go to status register. That's on a control register. So I'll open the status register inside user. If you go to your reference manual, go to user status register. So you need to set the bit 7 here, TXE, as enable. So if you go to bit 7, you need to see whether the transmit data register is empty. So this is set by the hardware from the transmit data register, and once it's ready, it can be transferred to the shift register, and once it's ready, the TXEIE 1 bit will transfer by setting to 1. So that's what we have written here in the code. So in the status register, we are setting 0080, meaning bit 7. We are enabling bit 7 as 1. So if we calculate that, this will be 0000 and 0001. So that is nothing but 8. So that's what I have written. 008 and last bit as 0. So this is what written as here 0080. And then once the transmit data goes through and make sure the register is empty, then you setting the TXEIE bit to 1. So this is what you sending the character to data register. Bit 7 you setting this one as the shift register. So that's what I have written here. So that's the USART write. Now we'll go into USART read. So for the USART read, you got to use the same. I'll copy this first. I'll explain. USART2. In the USART2 on the status register, now we need to enable the RX, which will be 0020, I think 0020. Okay, 0020, and you are returning the value on the data register. So for read, you just return on data register. Okay, while not equal to PSR with the status register. So again, you go to status register and you are enabling RxNE, read data register not empty, bit 5. RxNE, so you are just enabling that. So what will that do? This will be 0 and this will be 10. So this will be 0010. So that means this is 2000. That's what I have written here, 0020, and you're returning the value in user data register. Then to write the printf, you need to send the check the value in printf. So for that you have to copy from your syscall. As you remember, if you open syscall, you need to use this put character, this variable. So copy that and go to this main. I will paste here and remove the excess in character off. And what are you going to say? Whatever you write, the USART2, that will start to operate. So USART2 of character and then return the same character. Yeah. So now we have written the USART2 write and read. I'll go and compile the program to see if there is any fault at this stage. So it is a good practice as you go along and you write certain lines of program, and if you do compile, because it's already 100 lines of program, so you don't know where you will go wrong in case if you got any mistake with your typing error. So that's why it's a good practice. Once you write one function, go and build so that you target for 0 errors and 0 warnings. Okay, so now let's write program inside the main. So this is now we need the character call, so we got to enable the character here. I will do a tab to be clear. Yeah, and then put a simple while loop to just write the condition to print. So first you got to call the USART2 initialization to get all the registers. Call that. Then I'm just printing some value. So I'll say enter into the USART2 protocol loop. This is just for identification. So in the Arduino IDE, you are calling. So this is just for identification. identification. Okay, so we just print, and now you need to read the data. Today we are transmitting and receiving, so I'll just put a simple while loop of 1, and you're going to read the value from user read control C, control V, user read of what you need to read off from the character you got to read. Okay, so that's user read. Then whatever you're going to type, you're going to check in the printf statement as well. So printf data you have typed is, you can write anything, but I'm just writing this in the com, and then you have to write \n. You want to read which data? The characters, so you got to remember that channel. Okay, so that's all the main program we have done. So save that and go and build to see you have written a correct program. So at this stage I will minimize this and go and 2 errors. What? Printf, oops, sorry, I forgot the semicolon. So build again, build. Yeah, it's happy now. Warnings are okay as long as you don't have any error. That's what it really matters. So warnings are pretty much okay. Okay, so at this stage I will minimize this and open the Arduino so that I can show you the output in there. So I'm going to set this to debug STM32 application. I will also open my board view so you can see the hardware. So that's the hardware connected, and as you can see the LED is on. So it's changing the mode from debug C++ to debug perspective, so it will take some time. It's still loading. I'll do another debug. Let's see if I can make the process faster. No, it's not happy, it's still loading. Okay. It should load shortly, otherwise I'll ask again. STM32 application. Yeah, it started to convert 51%. Patience is the key as we learn everything by scratch and starting. So this take a bit of a maneuvering and waiting, but I'm sure it is well worth the wait. Okay, so we are here and in debug mode. We'll go and set up Arduino IDE. You got to select the board, so you know it's on the target is connected to the via COM3 and the device manager, and you just click on Adapfruit, just click OK, and you got to go to tools, serial monitor, and serial monitor, and come here in the IDE, hit run, go to the IDE, see it's communicating, so it has entered into the user2 protocol loop. So whatever I'm going to type here, it will convert that as a data. So if I type A, data I have typed is A, and it's waiting for the next value, anything. So I'll type as A to digi, because we are talking about single character, so doesn't matter whatever you type, it will take as the first character, so it's only showing A. So you're going to type B, the data is B, CD for example, it will type as CD, but A to digi, it's only taking the first two characters as to read. Yeah, okay. So we have learned to type in serial communication, whatever you type, it sends the data, that total package of data, and it is coming out as the output. E, type E and F. Okay. So now we're going to verify with the LED blink as well. I'll show you this LD2 blink with just modifying a little bit in the main program. So we are in the main program, and I'm going to include the type in the serial to blink that LED. So for that, I have to channel user read off. Just here I'm going to give a if condition. So if if value means if value equals A, like if I enter A as a value, then do this, else do this, simple. So in my if ch equal to A, so we got to connect to the LED. So this is where the output data register we got to use. So connect that output data register, because this register is PA5, it's connected to PA5. So just R-ing, meaning setting the LED to glow. One unsigned is setting this to glow, so that means LED is on. So likewise, if I type any other letter, doesn't matter, whatever I type to make it go off, then all I have to do is come here and I got to negate this to turn the LED off. Shift and negate, and this will turn the LED off state. LED off state. Okay, let's compile and check that in the board now. So I'm going to save this program, right click, build the project, so it will build. Yeah, and now I will download this program to the target board. So to do that, I got to type that. It's doing 70%, so once it hits 100, then it will be downloaded. As you can see, this LED is flashing there. This LED flash. Okay, so we are in debug mode. So it's just connected to debug mode. Okay, I'm going here and I'll set this not connected. Okay, connected. Here in the loop. So I will run here and come here into already I set up. So if I click on A, watch this LED, the green LED, that's the LED, it will come on. So I'm typing A and enter, it won't come because I typed a different character, so a small a. See the frequency, that's it's very short, so you just saw the blink come and go. A, just watch carefully. It came because there is no delay, so it won't stay for long. So we haven't written any program, so if you type any other word, you can't get that LED to blink. It will take that value, but it won't blink. But if you type A, because we set that to LED on, see that small flash. Okay, I'll type again A. See that flash, LED flash. Once more, I'll type A, you will see the LED flash. Yeah, the LED flash is there. So we learned today about transmitting a data and receiving a data, and also we checked on the hardware, so it's working. It's also shown the example in the serial hyperterminal as well. So we learned how to send the data and how to receive the data. So I'll just recap. First, you got to copy all the memory addresses by going to Windows, Show View, SFRs, and you got to copy all these registers from here. That's the first step. So you need to understand, you need to enable the clock for your GPIO port, and the second step is to enable the clock for USART2. Then you need to set the GPIO, the port for alternate function, because we're learning today to receive as well. So PA2 is set for USART2, so you need to set this 2 registers, 2 bits, and then USART2 as receive 6 and 7 bits, and then you need to see the output, because I showed you the output on the LED, so you have to set that GPIO mode as an output mode to connect to LDD2. So that's what we did here, and then we are using a USART2. So to do that, you need to set USART2 TX. You need to use these 4 bits. USART2 underscore RX for PA3, you need to use these 4 bits, and then you are setting the baud rate to maintain both on the same speed so that you can transmit and receive data. That's what we did. And then we are enabling the transmit enable on the USART and the receive enable on the USART, and then the USART enable finally. So these are all the steps, and then you're writing the character, waiting for the transmit data register to go empty, and then you're setting that bit to 1 to read in the data register. So the in the read, you have to enable the RxNE, so that's why the 0020, and you're returning the value from the data read. And the int IO put char is for print F statement, so you need to write that from the syscall. And this is the main program, so you just created a local variable, and then you call the USART function here, and then just for identification you are into the USART mode, and then whatever you type you read here. If channel A, if CH equal A, then we learned about to blink that LED and switch up that LED, and then you're printing it as whatever you type. For instance, A, that will be typed as A. If you type anything else, that will come as 0. So That's good. We learned today a lot. So let's go in and see the rest. Okay, we covered that. So what we learned today so far, I just gave you a small cap about the UART and the USART definition, and how the different mode of communication, the synchronous communication, asynchronous communication, and also I have taken you to tell you all the UART receive RX learning programming steps. So we learned that, and I also given you a big demo about each and every line, how you transmit and how you receive data. As I said right from the start, you also have to develop your mindset as well. So the more you indulge that, it is good for you. So these are the 3 points I would like to bring it to you today. The power of repetition. You got to tell your mind and make your subconscious mind tuned for success role. So keep saying, keep thinking about negative things, and keep going back to your goals and reread it. And also all the positive affirmation, you reread it so that your mind and your subconscious mind sets to success. So the more you being in a positive frame of mind, the more you repeat yourself, you will end up being successful. So that's what the first point is. The second point is you got to learn, unlearn and relearn. What that is, sometimes your own personal experience may put you into a bit of inconvenience. Meaning you think that you will know everything and then you go and do it. Occasionally it may not work. So in that case, you need to unlearn. You need to pretend that you haven't learned anything, and you need to start to learn again. And to do that, you need to relearn again. So always accept any sort of input, any sort of feedback, anything from your teachers, your mentors, or anyone got the experience. In that way, you will also open up your mind and you will learn more. Don't be so accustomed to your own self. Please be more open-minded so you can also receive more information and make you grow professionally as well. And then the third one is the law of attraction. There is a movie called The Secret. If you go to YouTube, please watch this video, and that video shows you all about today's mindset lesson. And please don't forget about the involvement. If you write the top 10 goals, you get a point, and top 10 ideas to achieve that goals. And then please spend at least 30 minutes to do the workout or go for a walk, and then spend 15 minutes to do your meditation, and 10 minutes to visualize actually achieving those goals. And then 10 minutes to have a daily plan for today, for the rest of the day, and for the rest of the week. And 2 hours of learning will get you 2 points. So please post all these achievements in the Facebook group, so everyone gets motivated and learn from each other. So we are here to help each other. So your achievement will boost others as well. So that's why I give you this small involvement, just to prepare your mind away from learning. So this will also help. There is combo internship coming up. I don't want to cram you into one module, so I separated into 3 modules. To get the full benefit, please purchase all the 3 beginners and intermediate and advanced to get the whole Cortex M series. Not only that, these are all in the process, and you will be the first person to know. So all these courses are coming your way. This is to upgrade yourself, to update yourself. So please stay tuned and stick by us, and you will be a better version of you. And I take this opportunity to thank you so much for each and every one of you for your patience to learn today. And you learned today the USART RX, which is one of the first communication protocol. And go and enjoy that lovely break from the screen, and I will see you on the next session. This is Arul. I'm signing off on behalf of A2DG. Huru for now. I'll catch you in the next session. Until then, take care, and I'll catch you later. Take care then. Bye for now.